The problem tells us that the range of a given projectile is given by the equation r is equal to the velocity squared in meters per second over 32 times the sine of 2 times the angle theta. And the problem tells us that the velocity is equal to 2500 meters per second and that the angle is changed from 10 degrees to 11 degrees, and it asks us what is the change in range. So to get the change in the range, simply we need to plug in the values. For example, r is equal to our velocity squared, which is 2500 squared over 32 times the sine of 2 times our angle, our first angle, which is 10 degrees, which in change gives us 66,800.8, and to do the same thing by plugging in 11 degrees, which in change gives us 73,165.35, and to get the difference we do a simple subtraction from angle 11 and angle 10 like this. Which results in 6,364.5 feet.
Yeah. So for letter B, they ask us use the differentials to approximate the change in the range. So what we have to do is to get the prime number, the prime of this equation. So it will be dy equals, r first b squared over 32 times the derivation of sine would be, which the u would go here, so it's 2 cosine to theta. Now what we have to do is change here to dy over dx, and dx goes right over here. So now what we want to do is to get the number for dx. So we do this, dx over theta 2 minus theta 1. That will be dx over dx equals 11 minus 10 equals 1. So what we have to do now is to plug in all the numbers. The theta inside the cosine is always the first one. So what we have to do is dy equals, plug in the velocity, 2500 squared over 32 times 2 cosine 2 times 10 times dx, which is 1. After we do all this, we put in the calculations, our answer will be dy equals 367.43 feet. Yeah. So for number C, letter C, they ask us interpret your results within the context of the situation. So what we can see here is that our answers are kind of wrong. So for number A, we got the exact number, and for letter A, we got the exact number, and for letter B, we got the approximation, which is hundreds of thousands of feet incorrectly. It's pretty much wrong. So in the context of the situation, we can see that it will be better to use the letter A, the example of letter A. yeah, that we will have a pretty big difference from theta 1 and theta 2. So theta 1 will be lower, and with the approximation we will go way up there and higher.
So letter D asks us under which circumstances is it better to calculate the actual change, and it is better to calculate the actual change when you are looking for an actual measurement of the projectile. And it also asks us when to use the approximation, and we believe that the approximation should be used maybe just for an estimate, to see, to compare it with your actual results in the experiment in the event of the throwing of a projectile.
To solve this problem, we need to integrate. One of the most common methods of integration is by substitution, but we cannot do that, because if you can see, there are 3 x's. And by substitution, you need a difference of x's by 1, and as you can see, there is none, so we cannot use substitution. So instead, we need to solve the problem normally. We do that by rewriting the problem and then we solve appropriately. And then we do FOIL. And then we actually integrate. If you leave the answer like this, it will be wrong, because you cannot have this. You need to rewrite it so it would end up like this. And remember to use proper notation.